Hey folks, we've spent the past few weeks talking about moderation. Now we are going to shift gears and spend the next few weeks talking about mediation, starting with a basic review of simple mediation, which we first talked about last spring. Before we get into examples of mediation, let's one more time make sure we're clear on the difference between moderation and mediation. Two very similar sounding words, but very different sounding concepts. In each case, we have a bivariate relationship between two variables x and y, and a third variable m, which is either a moderator or a mediator of that relationship. With moderation, what we're saying is that the relationship between x and y is true for some people, but not other people. Or maybe the relationship between x and y is stronger for some people and weaker for other people. The moderator is that third variable that tells us the conditions under which the xy relationship exists, or the conditions under which the xy relationship is stronger versus weaker. In other words, a moderator tells us when, aka the conditions under which x and y are related to each other. You can kind of think of the moderator as being like your light switch. It tells you when that relationship is turned on versus when that relationship is turned off. With mediation, however, we're saying that x and y are related for everyone, and our mediator is trying to explain why that relationship exists in the first place. So with mediation, there is a relationship between x and y, but m, our mediator, is the reason for that relationship. X predicts m, and in turn, m predicts y. So the relationship between x and y is dependent on the variable m. You may remember from last spring that we used process model 4 to test for simple mediation. Here's what that model looks like. We have a relationship between x and m that is mediated by a single mediating variable, which in this case is called m. We have two effects that we're going to parse apart. First, we have the indirect effect, which is the effect of x on y that goes through our mediator m. As we'll see in a few minutes, we can calculate the size of the indirect effect as well as a confidence interval for the indirect effect. If the confidence interval for the indirect effect does not include 0, then the indirect effect is not significant. We also have a direct effect of x on y. So that's the proportion of the relationship between x and y that is not explained by our mediator m. In a few minutes, we'll also see how we can compare the magnitude of the total effect against the magnitude of the direct effect to see whether the variable m explains all or only part of the relationship between x and y. If m explains all of the relationship between x and y, we would say we've found total mediation or full mediation. But if m explains only part of the relationship between x and y, we would say we found partial mediation. We'll make this decision by comparing the significance of the total effect against the significance of the direct effect. So as a reminder from last spring, our total effect is the overall relationship between x and y. We will then take that total effect and separate it into indirect and direct effects. The indirect effect is the proportion of the total effect that is explained by the mediator, and the direct effect is the remaining proportion of the total effect, which is not explained by the mediator. In other words, we're trying to figure out whether the mediator explains the relationship between x and y, and then also whether it explains all of that relationship or only part of that relationship. Let's look at our first example. Imagine we did a study which found that there was a relationship between religiosity and scientific literacy. Specifically, we find a negative relationship between these variables. As religiosity increases, scientific literacy tends to decrease. Once a study has established that relationship, the researchers might reasonably wonder, why is it that these two variables are related to each other? Why is it that more religious people tend to be less literate at science? These researchers tried to answer that question by measuring a potential mediator of attitudes towards science. Specifically, their prediction was that people who were more religious would have less favorable attitudes towards science, and in turn, people who have less favorable attitudes towards science would be less scientifically literate. Here's the data from this study in the data file McFatras and Zuckerman 2018. The three variables we're working with are our X variable, religiosity, which is called relig. Higher scores mean higher degrees of religiosity. Our Y variable is science knowledge. In other words, the participants in this study took a test to see how knowledgeable about various scientific concepts they were. That variable in our data file is called NC_psi. Our mediator, which is the variable that the researchers predicted would explain this relationship, is people's attitudes towards science. Do people generally hold a more favorable or less favorable attitude towards science? That variable is represented in our data file as psi_at, where higher numbers indicate more favorable, more positive attitudes towards science in general. As I mentioned a few slides ago, we will use process model number 4 to test for simple mediation. Again, our X variable is religious belief, our Y variable is scientific knowledge, and our mediator variable is attitudes towards science. So we'll put those variables in the corresponding spots where they need to go. Before we run the analysis, we also need to allow long variable names, which shouldn't be a problem here since they're all pretty short. And more importantly, in the options menu, we want to check the box for show total effect model. This will tell us about the overall strength of the relationship between X and Y, which we will then parcel out into direct and indirect effects. Here is the output from process. Now, from top to bottom, what this output is showing us is the results of 3 separate regressions. The first regression shows us the relationship between our X variable, religiosity, and our M variable, attitudes towards science. The second regression shows us how both X and M predict Y. In other words, it uses both religiosity and scientific attitudes as predictors of scientific knowledge. Our third regression, under where it says total effect model, tells us about the overall relationship between religiosity and scientific knowledge. On the right, we have a diagram of this mediation model. The first thing we want to do is pick out the relevant coefficients from the output and add them to our regression model. We'll start with the total effect, the overall relationship between religiosity and scientific knowledge. We represent the total effect with the letter C. As shown at the bottom of this slide, the value of C in this case is negative 0.22, and the very small p-value tells us that there is a significant and negative relationship between religiosity and scientific knowledge. As we predicted, as religiosity increases, scientific knowledge tends to decrease. So our total effect here, which we'll put on our diagram in parentheses, is negative 0.22, and we'll use 3 asterisks to indicate that the p-value here is less than 0.001. Next, let's look at the relationship between X and M, which we'll designate as A. The coefficient A here is equal to negative 0.05, and again, it is significant at p is less than 0.001, telling us that, as we expected, there is a negative relationship between religiosity and scientific attitudes. The more religious a person is, the less positive their attitudes towards science tend to be. Lastly, let's look at our middle regression. First, by looking at the relationship between M and Y. The relationship between M and Y, which we'll designate as coefficient B, is equal to positive 0.9, and again, it's highly significant, telling us that, generally speaking, people with more positive attitudes towards science also tend to have more scientific knowledge. Now, we can already tell we're going to find an indirect effect here, because there's a significant relationship between X and M, and there's also a significant relationship between M and Y. The question, though, is this full or partial mediation? In other words, does attitudes towards science explain the entirety of the relationship between religiosity and knowledge, or does it explain only part of that relationship? In order to answer that question, we have to find the value of C prime, which is the value of our direct effect. In this case, the direct effect, C prime, is equal to negative 0.18, and again, it's highly significant. What that tells us is we have found partial mediation here. The total relationship between religiosity and scientific knowledge is equal to negative 0.22. When we add our mediator, scientific attitudes, the direct effect decreases from negative 0.22 to negative 0.18. But importantly, that direct effect is still significant. So scientific attitudes explains some of the relationship between religiosity and scientific knowledge, but not all of it, because the significance didn't go away. Hence, we've found partial mediation. We could use the coefficients on this slide to calculate the indirect effect here. Remember that the indirect effect is always equal to A times B. So in this case, the indirect effect would be equal to negative 0.05 times positive 0.9. However, if we scroll down our output, we'll see that process also calculates the indirect effect for us. The output that we see here tells us the total effect and the direct effect, which we already knew, but it also tells us the magnitude of the indirect effect, which in this case is equal to negative 0.04. Remember that the direct effect plus the indirect effect will always equal the total effect. So in this example, the direct effect, negative 0.18, plus the indirect effect, negative 0.04, equals the total effect, negative 0.22. We already suspected that the indirect effect was going to be significant because both A and B were significant on the previous slide. However, we can use the confidence interval for the indirect effect to make sure that the indirect effect is in fact significant. Here are the two numbers that make up the confidence interval for the indirect effect, negative 0.07 and negative 0.02. Because those numbers are both negative, we know that 0 is not included in the confidence interval, which tells us that we have in fact found a significant indirect effect. So our conclusion here would be that generally speaking, people who are more religious tend to possess less scientific knowledge, and that relationship is partly explained by people's attitudes towards science. Specifically, people who are more religious tend to have less positive attitudes towards science, and people who have less positive attitudes towards science tend to have less scientific knowledge. Here's how the authors demonstrated their results in a similar looking figure. Notice their numbers are a little different from ours because they included some covariates that we didn't include, things like age, education, gender, race, and so on, which are explained in the write-up below. As a quick side note, they also report standardized coefficients, whereas we calculated unstandardized coefficients, because process, by default, gives us unstandardized coefficients. Unstandardized coefficients are measured in the original scale that the participants actually completed, whereas standardized coefficients are essentially z-scores. So this is something that I wouldn't personally ask you to do, But should you ever be in a situation where you want to do this, we can actually trick process into giving us standardized instead of unstandardized coefficients. Here's how we would do that. The first thing we would need to do is take all three of the variables in our mediation model, religiosity, scientific attitudes, and scientific knowledge, and standardize participant scores on those variables. The way that we would do that is we would go to Analyze, Descriptive Statistics, Descriptives. We would select those variables from the list on the left. And importantly, we would click the box at the bottom of this pop-up window that says Save Standardized Values as Variables. When we then click OK, SPSS will give us descriptive statistics in an output window, but more importantly, if we go back to Data View, we'll see that at the very end of Data View, we now have standardized scores for each of those three variables. All we then need to do is rerun this mediation analysis and process using the standardized variables instead of the original unstandardized variables. When we get our output, the coefficients will now all be standardized. Let's look at a second example. On average, women tend to report greater anxiety than men do. So there's a total effect of sex on anxiety level. Why does this relationship exist? These researchers hypothesized that this relationship can be explained by a person's physical strength. Generally speaking, biological men tend to have more physical strength than biological women, and in turn, they predicted that people who have greater physical strength would experience less anxiety. So here they're predicting a total relationship, a total effect of sex on anxiety, such that generally speaking, men have greater physical strength than women, and in turn, people with greater physical strength tend to have less anxiety, which would explain why overall men tend to have less anxiety than women. Here are the data from this study, and again, a diagram showing our mediation model. For each participant, we know their biological sex, where men were given a 1 and women were given a 2. We also know their anxiety score on the neo-neuroticism subscale, where higher numbers represent higher levels of anxiety. And they measured grip strength by using a dynamometer, which is essentially a thing that participants squeeze as hard as they possibly can, and it measures how strong their grip is in kilograms. What do we expect these relationships to look like? For sex, since man is coded as 1 and woman is coded as 2, we would expect a positive relationship. In other words, as sex increases, goes from 1 to 2, we would expect anxiety to increase as well, since generally speaking, women tend to have higher anxiety than men. Because men tend to have more physical strength than women, we would expect a negative relationship between sex and grip strength. As sex increases, we would expect grip strength to decrease. Finally, we'd expect a negative relationship between grip strength and anxiety, meaning that the stronger a person is, the less anxiety they tend to feel. Let's see if those relationships actually turned out the way that we thought they would. Again, using process model 4, we'll put the variables where they belong. Our x variable is sex, which is dichotomous. Remember that process automatically detects when a variable is dichotomous and dummy codes it for us. So sex, which was previously coded as men are equal to 1 and women are equal to 2, will be recoded as men being equal to 0 and women being equal to 1. But that doesn't really change our interpretation of the results because men are still the lowest coded number. Our y variable is anxiety score, where higher numbers indicate higher levels of anxiety. And our mediator variable m is grip strength, where higher numbers indicate greater physical strength. We've got some long variable names here, so we need to make sure that we allow those long variable names in process. And just like we did before, in the options menu, we're going to select the box to show the total effect model so that we can fill in the value of C on this diagram. Go ahead and run this analysis and make sure you're able to pick out the appropriate coefficients A, B, C, and C prime and add them to this figure. I'm going to ask you to pause your video now, find those coefficients, and add them to this diagram. Were you able to find the coefficients? I must have forgotten to add the asterisks to this diagram. Oops. So, the relationship between sex and grip strength, which is our coefficient A, negative 15.59, must be a significant relationship. Otherwise, the indirect effect wouldn't be significant. Sorry about that. Generally speaking, women tended to have weaker grip strength than men did. Our B path is also significant, even though I forgot to put the asterisks on the slide. As grip strength increased, anxiety tended to decrease. And finally, our direct effect, C prime, which was equal to 0.24, this part of the output tells us that the direct effect was not significant, with a p-value of 0.070. So here we have a significant total effect, 0.49, with a very small p-value. We have a non-significant direct effect, 0.24, with a large p-value. And we have a significant indirect effect, 0.26, and we know that the indirect effect is significant because the confidence interval, which stretches from 0.08 to 0.43, does not include 0. In other words, both of those numbers are positive. Because the total effect is significant and the direct effect is not significant, we know that we have found full mediation here. In other words, when we added the mediator to our model, the relationship between sex and anxiety became not significant, which tells us that grip strength explained all of the relationship between those two variables. How would we write up our results here? First, we're going to include one sentence that explains our total effect. Overall, biological sex was a significant predictor of anxiety. We're going to provide our C value as well as the P value that's associated with the total effect. If we wanted to be more specific here, we could add something like, such that overall, men had less anxiety than women did. Then we talk about our indirect effect. Because we used process, what we did was technically called a bootstrapped analysis. And that analysis revealed that the indirect effect was significant. We can give the magnitude of the indirect effect, which in this case was 0.26, and more importantly, the confidence interval for the indirect effect, which did not include 0. So what this tells us is that yes, there was an overall relationship between sex and anxiety. Women tended to have more anxiety than men. The reason for that relationship, according to these researchers, is how physically strong a person is. Specifically, because men tend to be more physically strong than women, and people who are physically stronger tend to have less anxiety, our mediator variable explains this relationship. Here we explain how the relationship between sex and anxiety went away when we concluded the mediator in our model. C prime, our direct effect, was not significant anymore. And what that tells us is that grip strength fully mediated the relationship between X and Y. For your practice problem for this week, which we'll talk about in a few minutes, this is exactly the sort of write-up that I'm looking for, in addition to the diagram with all of the coefficients on it. Here's how these authors reported their results. The first thing I want you to notice is that they pre-registered all of their hypotheses as well as their analyses in accordance with open science practices. First, they talk about the relationship between X and M. Between M and Y. Grip strength was negatively associated with anxiety. Then they talk about the relationship between X and Y. Women scored higher on anxiety than men. Most importantly, they say, there was a significant indirect effect of sex on anxiety through grip strength. Now, in their study, they actually included a second mediator, which is something that we'll talk about in 2 weeks when we talk about serial mediation. Here's what their model actually looked like. They had not one, but two mediators of the relationship between sex and anxiety. Specifically, what they found was that men tend to have stronger grip strength than women. So at step 2 in the model, people who have stronger grip strength tend to perceive themselves as more formidable. And then finally, at step 3 in the model, people who perceive themselves as more formidable tend to have less anxiety. So what we're essentially doing here is starting with this basic bivariate relationship and identifying the intervening variables that explain that relationship. So we end up with a chain reaction of sorts, where sex predicts grip strength predicts formidability, and formidability predicts anxiety. This simple bivariate relationship maybe isn't as simple as it seems, but now we have a better understanding of why those two variables were related in the first place. You'll also notice on this diagram that the direct effect between sex and anxiety, which was 0.25, is not significant, as evidenced by the fact that it has no asterisk next to it. What that tells us is that these mediators fully mediated the relationship between sex and anxiety. Here is the example that I'm going to base your practice exercise on for this week. There is an overall positive relationship between watching weather forecasts on television and believing in climate change. Generally speaking, people who watch weather forecasts more often tend to believe more strongly in climate change. The question is, why does that relationship exist? What is it about watching the weather on TV that maybe causes people to believe more strongly in climate change? These researchers hypothesized that our mediator variable is people's awareness of extreme weather events. Specifically, they predicted that people who watch more weather forecasts on TV are more aware of extreme weather events like hurricanes, heat waves, blizzards, and so on. And in turn, people who are more aware of extreme weather events happening have a stronger belief in climate change. This is the mediation model that I'll ask you to test for your practice problem for this week. Here's the data file, Bloodhart et al. 2015.sav. The diagram below shows the variables that I want you to include in your mediation model. The X variable is called watch forecasts, and it tells us how frequently people watch weather forecasts on television. Higher scores mean they watch those forecasts more often. Our Y variable, called CC_sure, tells us how certain participants are that climate change is real. Higher numbers indicate stronger belief in climate change. Finally, our mediator, which is called extreme weather VA, measures the degree to which a person is aware of the existence of extreme weather events. Higher numbers indicate a greater awareness of extreme weather events. For this practice problem, I want you to do 3 things. First, I want you to recreate this mediation diagram using whatever method you choose. You can use the template that's on our website, or better yet, you can try to create one on your own using Google Draw or PowerPoint or any number of other services. On that diagram, I want you to pick out the 4 coefficients, A, B, C, and C prime from the process output, and put them in the appropriate place on the diagram, using asterisks to indicate their significance level. Less than 0.05 means 1 asterisk, less than 0.01 gets 2 asterisks, and less than 0.001 gets 3 asterisks. Your write-up for this week is actually going to be quite short. It'll really only be 2 sentences, and it's not going to have a lot of numbers in it. In the first sentence, I just want you to tell me whether the total effect was significant or not. So overall, was there a relationship between watching TV forecasts and believing in climate change? If there was, I want you to briefly explain that relationship, whether it was positive or negative, and what that means. Second, you'll use the process output to determine whether or not the indirect effect was significant here. If it was significant, I want you to include the indirect effect, the confidence interval for the indirect effect, and in one sentence, I want you to explain the nature of the indirect effect. How exactly does this mediator explain the relationship between X and Y? So again, you can model your write-up after the one from the previous example. You don't have to worry about talking about full versus partial mediation here, but I do want you to have one sentence about the total effect, one sentence about the indirect effect, and a diagram that includes all of the coefficients and shows their significance level. Here's how these authors chose to explain their results. Now, this is another sneak preview of a topic that we'll talk about in a couple weeks. The results of this study seem to suggest that people who watched the weather more often believed in climate change more strongly. The question, though, is, does that relationship hold true for everyone, or might that relationship only hold true for certain people? Here we're getting back into moderation territory by talking about whether this relationship holds true only under certain conditions. When we combine moderation and mediation in the same statistical model, we call it moderated mediation, also known as conditional process analysis, which is something we'll discuss 3 weeks from now. Here is what the author's model in this study actually looked like. So we already looked at the middle part of this graph. Exposure to weather forecasts predicts perceptions of extreme weather, which in turn predicts belief in climate change. However, there may also be moderators of these relationships. For example, maybe watching more TV weather forecasts increases awareness of extreme weather events, but only for certain people, such as people who tend to trust in the accuracy of TV weather forecasts. Political ideology was another moderator that the authors identified. Maybe it's not the case that everyone who's more aware of extreme weather events believes more strongly in climate change. Maybe, for example, that relationship is only true for people who are more liberal as opposed to people who are more politically conservative. Again, you can see how things get very complicated here when we include both mediators and moderators in the same model. What we're talking about today is just the building blocks of how we will eventually get to these more complicated models. Two more quick examples to illustrate the limitations of what mediation can and can't do. These researchers found that there was an overall relationship between neuroticism and depression. People who were more neurotic tended to also be more depressed. But why does that relationship exist? These researchers hypothesized that that relationship might be explained by differences in sleep quality. Specifically, they predicted that people who were more neurotic would get lower quality sleep, and in turn, people who got lower quality sleep would be more depressed. We can test their model using the data file Huang et al. 2016.sav. Our predictor variable X is their score on the neo-neuroticism scale. Our outcome variable is their depression score, and our mediator variable is their sleep quality score on the Pittsburgh Sleep Questionnaire. We can use process model 4 just as we've done in the previous examples, putting these variables in the appropriate place. Our X variable is neuroticism, our Y variable is depression, and our mediator is sleep quality. And as we've done all along, we'll ask for the total effect model so that we can add all of our coefficients to the diagram. Here's what the output looks like. As we expected, there was a significant positive relationship between neuroticism and depression. People who are more neurotic tend to be more depressed. Our A path was significant. People who are more neurotic tend to report lower sleep quality. I should clarify here that higher scores for sleep quality actually reflect poorer sleep quality because of the nature of this scale. We also saw a positive relationship between sleep quality and depression. People who tended to have lower sleep quality, as evidenced by higher scores on that scale, tended to have higher depression scores as well. However, sleep quality only partially mediated the relationship between neuroticism and depression. We know that because our direct effect, C prime, is still highly significant. Our indirect effect here, which again is equal to A times B, comes out to 0.07. And our confidence interval, because both numbers are positive, does not include 0, tells us that the indirect effect was significant. So we may be tempted to conclude here that sleep quality explains the relationship between neuroticism and depression. People who are more neurotic don't sleep as well, and people who don't sleep as well tend to be more depressed. This is one possibility that the authors considered. However, there are other possibilities as well. Participants completed all three of these scales at the same time: neuroticism, sleep quality, and depression. None of those variables were manipulated by the researchers, so we can't draw conclusions about cause and effect in this situation. In other words, we can't be sure that sleep quality actually mediates this relationship. There are several other possibilities, and to their credit, the authors acknowledge this. In the top half of this table, they test the model that we just discussed. Maybe it's the case that people who are more neurotic tend to not sleep as well, and then in turn, people who don't sleep as well tend to be more depressed. So in that model, sleep quality mediates the relationship between neuroticism and depression. The authors recognize, though, that there's another possibility. Maybe in this model, depression is actually the mediator. Maybe it's the case that people who are more neurotic tend to be more depressed, and in turn, people who are more depressed tend to not sleep as well. The point here is, since none of these variables were manipulated by the researchers, and they were all measured at the same time, we can't be sure what order these things occur in. It obviously makes sense that neuroticism would come first, because that's a personality trait. But in terms of whether neuroticism affects sleep or neuroticism affects depression, we don't know which comes first. Does depression make people sleep worse? Or does sleeping worse make people depressed? It could be either. And statistically, a mediation analysis doesn't allow us to distinguish between those two possibilities. This is one major limitation of mediation analyses. If we don't manipulate the variables involved, in other words, if these are all correlational relationships, we don't know which variable comes first, second, and third. This article by Fiedler et al. Talks about this limitation in more detail. Here are 4 diagrams showing 4 different ways in which 3 variables, x, y, and a mediator z, could potentially be related to each other in the real world. A mediation analysis doesn't tell us which of these 3 things is actually the case. If we wanted to use mediation analysis to determine cause and effect, as with any other type of research, we have to manipulate the independent variable. In this case, we would have to carry out what's called an experimental causal chain design, meaning we would do 2 studies. First, we would manipulate the x variable and look at how that manipulation causes both m and y to change. Then we would have to do a second study where we manipulate the mediator variable to make sure that the mediator variable actually causes the y variable to change. Unless we break apart the mediation model in this way and separately manipulate our x variable and our m variable, we can never be sure that the model works in the way that we hypothesized it to. The problem is, many of these variables are things that we can't manipulate. For example, we can't manipulate how neurotic a person is or how depressed a person is. Maybe we can, but it would be very challenging to do that. Other variables we can't manipulate at all, things like sex, for example. In those situations, we could try using a factorial design by crossing the x and m variables together. We could try using a longitudinal design to see how those variables change over time. But in some situations, we might just be SOL. Our last example shows another paradoxical thing that sometimes happens in our mediation models. The research question behind this study was whether athletes who score higher in resilience tend to suffer fewer injuries. As it turns out, that is the case. If we measure the resilience of an athlete, we find that resilience is a negative predictor of the number of injuries that they suffered in the past year. These researchers hypothesized that motivation might mediate that relationship. However, as we'll see in a second, the direction of the indirect effect is actually going to be in the opposite direction of the total and direct effects. Here's the data from this study, Leon Guareno et al. 2016. Our x variable is resilience. Higher scores indicate higher levels of resilience. Our y variable is injuries, where a higher number indicates more injuries in the past year. And our mediator variable is intrinsic motivation to exercise. Higher scores indicate higher levels of intrinsic motivation. We'll run this model and process using model number 4, just as we've done all along. And we'll again ask for the total effect model so that we can get the value of C for our diagram. Here are our coefficients. The total effect, which is not significant, is negative 0.06. So overall, there was no relationship between athletes' resilience and the number of injuries that they suffered in the past year. Our A path was significant. Athletes who are more resilient tend to be more intrinsically motivated to work out. Our B path is also significant. Athletes who are more strongly motivated to work out tend to suffer more injuries, which again makes intuitive sense. Now here's the bizarre thing about this. Our total effect is not significant, negative 0.06. Our direct effect, however, is significant, negative 0.08, with a p-value of 0.04. We haven't seen anything like this, where we have a total effect that isn't significant, but a direct effect that's actually stronger than the total effect. In every example we've seen so far, both last year and so far today, the direct effect is always weaker than the total effect. Sometimes so much weaker that we have full mediation, sometimes only a little bit weaker where we have partial mediation. But what's going on here? Why is it that the total effect would actually get stronger when we add in our mediator? The reason for this is that the total effect and the direct effect are both negative, whereas the indirect effect here, the A and B paths, are both positive. They're working in opposite directions. In mediation language, this is called a suppression effect, and it occurs when the direct and indirect effects have opposite signs. Remember that when we're looking at a bivariate relationship, there might be many reasons why those variables are related. There might be some variables that facilitate that relationship, but there might also be other variables that suppress that relationship, meaning they actually work in the opposite direction and they make that relationship weaker. Here's a simple example of that. As you might imagine, Factory workers who are more intelligent tend to make fewer mistakes. So there's a negative total relationship between the intelligence of a worker and the number of mistakes that they make. However, imagine that we ran a mediation model where we looked at boredom as a potential mediator. People who are more intelligent are more likely to get bored at work. And people who are more likely to get bored are going to make more mistakes because they're bored and not paying attention. So here we have a negative total effect and a negative direct effect. As intelligence goes up, the number of mistakes goes down. But our indirect effect is positive. People who are more intelligent tend to get more bored, and as a result of being more bored, they tend to make more mistakes. Here's another example. People who experience a natural disaster tend to experience more stress, for good reason. One study, however, found that people who experience a natural disaster engage in more coping behavior, and as you would assume, coping behavior tends to decrease stress. So here's an example where we have a positive total and direct effect, but a negative indirect effect. The reason why this paradoxical thing can happen is that there are other mediators of this relationship that we aren't accounting for. In other words, just because we've identified one mediator doesn't mean we've identified all of them. And some of them might facilitate that relationship, and others might suppress that relationship. So the total effect is the sum of all of those intervening variables. Most of them are working in one direction, but in this case, we have one variable that's working in the opposite direction and suppressing that relationship. When this happens, it tells us that there must be other mediating variables that are stronger than the ones that we measured, and they're variables that we haven't accounted for. So we need to account for those variables in future studies. Starting next week, we will talk about how we can include multiple mediators in a model like this one. Back to our model. Our indirect effect here was significant, as evidenced by the fact that the confidence interval are both positive numbers. Here's what the researchers actually did. They measured not only extrinsic motivation as a mediator, but also intrinsic motivation as a mediator. And what they found was only intrinsic motivation, not extrinsic motivation, mediated this relationship. Though again, it was in the opposite direction of the total effect. Now, when they did this in their paper, they tested two separate mediation models, one that used extrinsic and one that used intrinsic. They could have, however, included both of those mediators in the same model. In other words, if there's a relationship between two variables x and y, and we think that there might be multiple reasons why those variables are related to each other, we can include all of those reasons as multiple mediators in a single model. We call that parallel mediation, and that's what we'll talk about next week. What that will allow us to do is look at the multiple reasons why two variables are related and make inferences as to whether some of those reasons are stronger than others.